So as my team at work has diminished in size, as some of our people have been moved from the legacy platform that I work on to the more modern platform, I find myself having to get more done with fewer people, which means that I'm trying to constantly find simpler ways to achieve a good enough solution. And one thing that I've started to use a lot more is this sort of brute force refreshing of data in the background, which allows me to keep the view model and the user interfaces in sync with a lot less complexity in my code. So to demonstrate, I have two browsers open here, and you can see that as I add a message here, I'm getting that message synchronized across screens. Let me actually lower that. We can see A, B, C, D, D. And here these things are coming into sync. I can delete messages, and you see that I'm synchronizing there. I'm actually doing optimistic deletes here, which can cause some problems, which I'll demonstrate here. If we add a bunch of messages, and then we try to delete them in rapid succession, what you'll see is probably some weird flashing of data. Well, maybe not. Sometimes it's hit and miss. So let's take a look at how I'm doing this in order to keep it in sync with as little amount of work as possible. So here is my app component, and I have my messages collection. And typically when I build a component that has to render remote data, what I start with is my init function, and inside my init function, I call this load remote data. The load remote data typically puts the component into a loading state where I set an isLoading flag of some sort to true. And if we look at the HTML, usually I have some sort of loading state and then a reading state. And if we come back here into the browser and we refresh, you'll see it flashes that loading state when I refresh, but not when I add new messages or delete messages. In this case, we're actually doing a background refresh, which doesn't set that isLoading flag to true, so we keep the user experience more seamless while still refetching data in the background. So my isLoading data sets the flag. It goes to my remote data service. It fetches messages. It then sets that isLoading flag to false, stores the messages into the local view model, and those are what are being rendered in our HTML view. Now there's more data, there's more stuff going on here, which we'll talk about in a second. But when we add and remove messages, what you can see is that we go to our remote data service, we perform the mutation, and then down here at the bottom, I'm calling this load remote data in background. And you'll see that in the delete message, I'm doing the same thing. I go to my remote service, and then I'm calling load remote data in background. Now the load remote data in the background, get there, does similar stuff to the load remote data in that it's going to the service, storing the view model, right? We're going to the message service, and then we're storing the view model. But what you won't see here is an isLoading flag being turned on and then turned off. And that way we can fetch the data in the background without flipping the user interface into that non-ready state, which would be much more disruptive to the user as they're interacting with the view. Now, the problem with fetching data from a remote service is that AJAX requests are by nature unpredictable in their latency. They have to deal with the network latency, they have to deal with the server latency, which means that if I launch multiple AJAX requests in parallel, there's a chance that they will come back out of order. So to simplify the request without having them step on each other's toes, typically what I'll do now is I'll keep some sort of a data fetch ID at my component level. And then if we jump down into my load remote message or load remote data, what you'll see is that the very first thing that I do inside of my function is I increment, or I pre-increment that value, and I store it into a function local variable. And then what happens is other requests that then get triggered in the meantime will also increment this value and also have their own local version of that ID. So after I fetch my data from the remote service, I can check to see if my local data ID still matches the remote data load ID. And if those are the same value, then it means that no other newer AJAX request has been triggered, and I can go ahead and consume this data. But if another request has been triggered, which means that it will have a chance of actually pulling back fresher, more up-to-date data, then my local data load ID will no longer match my remote data load ID because that will have been incremented by that other AJAX request, and I'll just ignore it and short circuit out of the function. And what you'll notice is that my load remote data uses remote data load ID, as does my load remote data in background. So these two functions track AJAX requests using the same variable, which means that they won't step on each other's toes. And you can see this in action. Let's start fresh here. And, let me just do it in this one since we have the full console open. So if I rapidly delete a bunch of these messages, what you'll see is that some of the requests are being ignored. And what happened is each one of those deletes eventually triggers a refetch of the data in the background. But because those AJAX requests are subject to a random latency, some of them are going to come back out of order, in which case we just ignore them, and eventually we just apply the most recent AJAX response to the view, which of course has all the data removed. And if we jump over here, you can see that this one also has all the data removed as well. So you might look at something like this fetch ID and ask, well, can't you just use something like RxJS's switch map in order to cancel the previous request and then follow only the newer request? You probably could. The reason I don't do that is twofold. One, I typically work actually in AngularJS, even though this is modern Angular here in the demo, which I don't have RxJS on hand. But the second reason, which is probably more relevant, is that I just don't really understand RxJS. It confuses me. I find it hard to debug. I find it hard to follow. I understand promises, and to me, this just feels like an easy way to wrap my head around the situation. So your mileage may vary. So let's take a quick look at the message service here, because what you'll notice is that when I initialize this app component, I'm actually subscribing to changes in the message service, and then I'm calling that load remote data in background. And that's why when I add a message in one tab, it synchronizes in the background, because I'm listening to those events. Now I'm actually using local storage under the hood, and I'm listening for storage events on the window, which get triggered by other tabs that update the same local storage API. But I also have what you can see is latency in all the synchronization, and that's because I'm actually just simulating network latency on top of my local storage. So let's just take a quick look at that. So here's my message service, and here's my storage key. So I'm storing all of my demo data into this one key within local storage. And here you can see I am starting to watch storage. So if we jump down to watch storage, what you can see is that I'm listening for the storage event on the window. And then if the relevant key matches the key that I'm using for my demo, then I'm just looping over a set of callbacks and invoking them. And that callback is this here, which ends up triggering the load remote data in background. Now, of course, because these all use that, because these are all using this, if I have multiple local storage events that trigger in tight succession, they won't end up overriding each other. Well, because they'll short circuit out just below. So the message service, as I said, it has some simulated network latency, because even though it's going to local storage, which has essentially no latency, although that's not true, I want to make the demo more realistic. So at the top of each of these calls, I'm just calling this simulate network latency before I actually perform the actions. And if we jump to that, all right, I don't know why it's not working. If we jump down to my simulate network latency, what you'll see is that it's just a promise that uses a set timeout to invoke the resolve after some random amount of time that's between 100 milliseconds and essentially 1 second and 100 milliseconds, because it's aggregated there. And yeah, so is this a perfect solution? It's not a perfect solution, right? I mean, let me see if I can demonstrate that weird flash here. If I rapidly, so sometimes if I rapidly, I don't know why I can't even trigger it this time. Sometimes you get a weird flash of data. So it's not a perfect solution. There are definitely types of interfaces where this wouldn't make the most sense, especially interactions where there's a rapid succession of user interactions and you really want to be optimistically updating data based on events so that you can keep the interface in sync in a very tight way. This brute force refreshing probably is not the right approach. But I think in the vast majority of user interfaces that I build, this brute force refreshing is good enough to keep the interface up to date without creating a janky experience for the user. So again, I'm just trying to figure out how to do more with less, how to move more product with fewer people in a smaller team. And this has been definitely a nice way for me to help get that done.